This discovery was pending for a long time and could potentially help us track back time to the creation of it all. Launched last December as a successor to Hubble, the James Webb Space Telescope is making breakthroughs at a surprising pace. The Webb Telescope has made yet another discovery, one that could be of great importance to scientists and astronomers. Let's go! The James Webb Space Telescope is the largest, most technically advanced telescope ever built. The $10 billion observatory, the largest and most powerful telescope ever sent into space, is in solar orbit, 1 million miles or 1.6 million kilometers from Earth. Full science operations began over the summer, and NASA has since released a series of dazzling snapshots. Its larger size and richer infrared views will allow it to go beyond Hubble's deep field observations to peer back over 13.5 billion years, witnessing the first stars and galaxies forming out of the darkness of the universe. By comparing the faintest observations and earliest galaxies to majestic spiral and elliptical galaxies we see today, James Webb's observations can guide our understanding of how galaxies evolve over billions of years, building upon the work of astronomer Edwin Hubble and his namesake telescope. Now, what's different about the James Webb Space Telescope that the Hubble didn't have is not only its size. Hubble can observe in near-infrared light, but it was optimized for shorter ultraviolet and visible wavelengths of light. Webb's 21.3-foot primary mirror is also significantly larger than Hubble's 7.9-foot primary mirror, giving Webb more than 6 times the light-collecting area that Hubble has. It is important for the longer and dimmer wavelengths of light Webb sees. The way it operates is that the 21.3-foot wide mirror is equipped with 4 sensitive cameras along with spectroscopic detectors operate at less than 50 degrees above absolute zero. The ultra-low temperature is required to enable the telescope to capture faint light that has been stretched into the infrared region of the spectrum by the expansion of space itself over the life of the cosmos. So what is it that the new $10 billion James Webb Observatory has discovered? Just weeks into its mission, the James Webb Space Telescope, or JWST, has broken the record for the oldest galaxy ever observed by nearly 100 million years, seeing some of the first galaxies to form after the Big Bang 13.8 billion years ago is one of the key goals of the JWST. When these emerged is currently unknown. The previous oldest identified galaxy found by the Hubble Space Telescope is called GNZ11 and dates back to 400 million years after the birth of the universe. The JWST has found an unexpectedly rich realm of early galaxies that has been largely hidden until now, beyond the reach of other telescopes. Researchers have found 2 exceptionally bright galaxies that existed approximately 350 and 450 million years after the Big Bang. These and other observations are pushing astronomers toward a consensus that an unusual number of galaxies in the early universe were much brighter than expected. Although some researchers report having uncovered galaxies even closer to the creation of the universe, 13.8 billion years ago, those candidates have not yet been verified, scientists said at NASA news conference. Some of those could be later galaxies mimicking early ones, they noted. 2 research papers led by Marco Castellano of the National Institute for Astrophysics in Rome, Italy, and Rohan Naidu of the Harvard-Smithsonian Center of Astrophysics and the Massachusetts Institute of Technology in Cambridge, Massachusetts, have been published in Astrophysical Journal Letters. These initial findings are from a broader JWST research initiative involving 2 early release science, or ERS, programs, the Grism Lens Amplified Survey from Space, or GLASS, and the Cosmic Evolution Early Release Science Survey, CEERS. With just 4 days of analysis, researchers found the 2 exceptionally bright galaxies in the GLASS JWST images. These galaxies existed approximately 450 and 350 million years after the Big Bang, with a redshift of approximately 10.5 and 12.5 respectively. Future spectroscopic instruments with JWST are still needed to confirm their distances. The $10 billion telescope was launched into space on Christmas Day, 2021, to observe galaxies formed after the Big Bang. It is also studying the atmospheres of planets inside and outside of our solar system, so scientists can learn more about the evolution of the universe. The first image of the telescope, revealed by US President Joe Biden on July 11, was of the galaxy cluster SMACS 0723, as it appeared 4.6 billion years ago. Another surprise was the discovery of galaxies with compact disks at such early times, which was only possible because of JWST's much sharper images in infrared light compared to Hubble. It was emphasized that the two bright galaxies found by these teams have a lot of over-brilliant light. One possibility is that they could have been very massive with lots of low-mass stars, like newer galaxies. Alternatively, they could consist of far fewer extraordinarily bright stars, which are also known as population 3 stars. Long theorized they would be the first stars ever born, blazing and blistering temperatures, and make up only of primordial hydrogen and helium, before stars could later cook up heavier elements in their nuclear fusion furnaces. No such extremely hot primordial stars are seen in the local universe. The ages of the newly discovered galaxies are not yet fully confirmed. Additional spectroscopic analysis is required for that, but astronomers said the observations show clear signs of numerous potentially older galaxies, which would push star formation back even closer to the Big Bang. Present Webb distance estimates for these two galaxies are based on measuring their infrared colors. Eventually, follow-up spectroscopy measurements showing how light has been stretched in the expanding universe will provide independent verification of these cosmic yardstick measurements. According to lead astronomers, this newly discovered throng of stars would surpass the most distant galaxy identified by the Hubble Space Telescope, a record holder that formed 400 million years after the universe began. Tommaso Trio of the University of California, Los Angeles, a chief scientist for Webb's early release science program, said the evidence presented so far is as solid as it gets for the galaxy believed to have formed 350 million years after the Big Bang. If the findings are verified and more early galaxies are out there, Radu and his team wrote that Webb will prove highly successful in pushing the cosmic frontier to the brink of the Big Bang. No one yet knows when the first stars turned on after the so-called Dark Ages ended and light first began to travel freely through the universe. As the name implies, the extremely distant galaxies were found in light being gravitationally magnified by the mass of a nearer galaxy cluster. Remember, light doesn't travel infinitely fast, so when we see objects across the universe, we're looking far back in time, as they were when their light left them. As the light of distant galaxies travels across billions of years of space and time, the light is shifted toward the red end of the electromagnetic spectrum. The amount of redshift scientists see is symbolized by the letter Z. Before Webb, the farthest galaxies previously known in our universe were GNZ11 and HD1. As you can tell from GNZ11's name, its redshift factor, or Z, was 11. Scientists said it existed when the universe was about 400 million years old. HD1 was discovered in April, however it was the record holder for just a few months. Now it appears that Glass Z13 existed at a time some 30 million years before HD1. Glass Z13 isn't the only distant galaxy that astronomers are reviewing. They're also expecting a galaxy named Glass Z11, which is also a candidate for one of the earliest galaxies we've ever seen. Both of these galaxies are tiny in contrast to the galaxies we see today, such as our home galaxy, the Milky Way. The Milky Way is about 100,000 light-years in diameter. Scientists don't think that finding this second, more distant galaxy was just luck. As they said in their paper, these two objects already place novel constraints on galaxy evolution in the cosmic dawn epoch, the period from about 50 million years to 1 billion years after the Big Bang. They indicate that the discovery of GNZ11 was not simply a matter of good fortune, but that there is likely a population of UV luminous sources with very high star formation efficiencies. In other words, there are likely more galaxies at a distance that are forming stars in that Webb, with its sensitiveness in the infrared part of the spectrum, we'll be able to see. This is crucial to understanding the timeline of the universe and the Big Bang. This calls for our favorite line from the mighty Buzz Lightyear, to infinity and beyond. Hope you found the video interesting and informative. Thank you for watching. Please don't forget to subscribe to Beyond for more amazing content like this. As always, see you all in the next one.